Let's take a look at the solutions to the review for exam 3. Here are the problems. They're not written on the following pages, so if you don't have these, you should copy them or write them down. So for the first question, we're given a function, and it's on a closed interval, and it's f equals 7. Well, we know this guy is just a horizontal line, and it occurs from -9 to 9. To do the process, we take the derivative, set it equal to 0, but there are no critical values. Remember, when we have critical values, we get x equals a number here. So this is saying this is always true. And so what a lot of students will say here is that there's an absolute max of 7 and an absolute max both at x is 9 and positive 9, and this is the important piece, at all x values from -9 to 9, because they all have the same x value. The next one's a little bit more traditional. We have a function, we don't have an interval, take a derivative, set it equal to 0, find the critical value. Yes, you have to say there's exactly 1, because that's what lets you then do a concavity check. Concavity check is take the second derivative, first derivative here, second derivative is just 4, which is greater than 0 for all reals, which means you get this, which means you get a min at 4. Now go find that y value you have an absolute min of, and then you find this by substituting 4 back up into the original function. And there is no absolute max. For the next problem, we're being asked to find the number of the months in time until we get a minimum for the price. And so here's the function they give us. T is in months. T is for the minimum, the time we're looking for minimum price. That's our question. So this is our question. And so the first thing we do is take the derivative of our function, set it equal to 0, find our critical value. Now this is an open interval. We have to have just 1, so we say, yeah, we found just 1. So let's do a concavity check. Take the second derivative for this guy. It's 380, which is greater than 0 for all real numbers. That means it looks like this because it can hold water, which means you have a relative min at that critical value. So the price is going to be minimized after 80 over 18 months, which doesn't make much sense for this one. You are going to need to approximate, because who says 80 over 19 months? So you give the exact answer, and then you give the approximate answer. And then you're done for number 3. For number 4, they give you a revenue and cost function, find the number of units you have to produce and sell to get the maximum profit. Now they don't ask you for the maximum profit, they just ask you how many units. So let's go find how many units. The profit is going to be revenue minus cost, and you're given both of those. So revenue minus cost, negative distributes in, simplify by collecting terms, take the derivative, set it equal to 0, you get exactly 1. So you say, oh, I have exactly 1. I'm going to do a concavity check. P double prime, so take the derivative of this guy, you get -1 is less than 0, can't hold water, that means it's a max. So you're going to maximize profit with 33 units, which is what your critical value was that you found. 4 is a little bit different, and they give you a lot of information, and then you have to do something with it, right? They have 260 units. The hotel is full when they charge just $80 a day. That's not going to be their maximum profit, but they do have a full house. So for every dollar they raise it, they drop 1 empty room. And so that means if the price is $81, they have 259 sold. If the price is add 10, $90, subtract 10, you get 250 units. If they add $17, then you take away 17 units. And so we can go ahead and write the price based on that, which is going to be X plus whatever the 180, the 80 is. And so here we get price is that. The quantity is going to be the number of rooms, 260 minus however much we're adding the price. Go ahead and FOIL that out. The cost they tell they're going to charge us $22 a day for occupied rooms. And so the cost is going to be however many rooms I have times the cost per room. Go ahead and multiply that in. You get this plus, I see it cut off my x, 22x. And then you're going to go ahead and subtract cost from revenue. And when you simplify that, you get this function here. So now we do what we know how to do. All of this was just find the function. Once you have the function, take the derivative, set it equal to 0, get your critical value. You have exactly 1. Concavity check. Second derivative, -2, which is less than 0, concave down, so it's a max. That means we have 101 rooms vacant. But the question they're asking us is how much should we charge? But remember, the number of rooms that's vacant, X, is also what we're adding to the price. So add 101 to the 80. So you want to charge $181 to maximize your profit. For number 6, for this one, we're given this function, it's got cubics, and what you know is going to happen is you're going to end up with quadratics in your first partial order derivatives. And then some people think it's a mess, but it's a process we work through, right? And so here's our original function. We're going to do this in 4 steps: partial derivatives, solve the system, do the d-test, and then draw a conclusion. And so partial derivatives, take them with respect to this guy, and then second order here. That's old news. Now, we write this f sub x, f sub y equals 0. Really, it's saying solve the system. We write this because it's just faster. We write f sub x equal to 0, f sub y equals 0. So go ahead and solve this first one for y. Add the 9y to the other side, divide both sides by 9, and you get this. Now take this guy and substitute him into the other one. So it's the substitution method. So what do you get? 3 times that quantity squared minus 9. This is where a lot of common error is occurring. People aren't showing their work by substituting, and they're forgetting this guy. When you square that, you get 1 over 9x to the 4th. Now multiply the 3 in to get 1/3. Well, that fraction, we can get rid of that fraction by multiplying through by that constant. So multiply by 3 right here, and when you do that, you get then x to the 4th minus 27x. But what we can do is GCF. Now you get this guy. This is 3 cubed. I see the little 3 guys cut off. 3 cubed. Use the formula for the difference of 2 cubes. And when you do that, you get x is 0 and x is 3. And then no real number from this guy, because inside, for the quadratic formula, the discriminant b squared is 9 minus 4 times 1 times 9. That's a negative number, and that means you have no real solution. Now that we have our 2 points, we can go ahead and do the d-test. And yeah, we got to do it for both of those values. So here it is for 0, 0, and here it is for 3, 3. You've got formulas for f sub xx, so you got to go find those values, substitute everything in. When you get d is equal to a number that's less than 0, you get to say it's a saddle point. Go find the z while you're here. And then over on this one, calculate those partial order derivatives, put them into your d, find the d, here he is. And he's greater than 0 here. When he's greater than 0, he could be a max or min. So that means we've got to check concavity. And all you do is pull that f sub xx for this point. We already found it. It's 18. Since it's greater than 0, it holds water. That means it's a relative min. Go ahead and find that z value. Now you're ready to give your conclusion. So you have a saddle point at that ordered triple, and then a relative min at this ordered triple. And so what you see here are 4 parts to this question. And when you're asked this kind of question on a quiz or exam, you need to be able to do step 1, step 2, step 3, and step 4, and separate your work in that way. If you're unable to do that, it's going to be really difficult to read your work. So space has been given so that you have them split up like this. Sorry, mine's bleeding down because I didn't have the lines already. and keep your work within those lines. For the next one, this one, move them down so you can see it. Here we have the 4 parts again. 1, 2, 3, 4. So you would have 4 steps on your solution sheet where you're able to, here's 1, 2, 3, 4. Let's walk through partial derivatives, super short and sweet. It's a nice function. You're going to solve the system of equations, set each partial first order to 0, get yourself some variables. So our CV, or critical point, is going to be 0, 0. We only have 1 to test, so we go ahead and test the D value, which is less than 0, so you get a saddle point, find the Z, and you're done. That's how quickly those problems can be done, but you got to know the order of operations. For number 8, this problem was given in class, and so it was on the front page as handwritten because we had to change it. And you got 4 parts of this one again. You got 2 variables. That's how you know you have to do the D test again. And so take your partial derivatives with respect to M and T. That's the amount of advertising dollars on magazines, the amount of advertising times dollars on TV. Find all the second orders as well. Solve the system. When you go to solve this system, you can take the second or the first guy, doesn't matter which. I took the second guy, solved it for M, so M is 4/13. Then I went ahead, went ahead and, I quit putting my values here, bad. Solve this guy for T and then put T in here for M to find M. You gotta label these as M and T. Those are your 2 values, number of dollars on mags and number on TV. We gotta do our D test now. When we do our D test, substitute your values in. It's greater than 0, so it could be a max or min. So we have to check that first order, second order concavity. So this is the concavity check. We keep calling it a concavity check just because it's funny. And so we do that concavity check, and it's going to be facing down, so it's a max. Go find that Z value. For this one's a little different than the last one because you've got to go ahead and give your answer, and it's got to be with respect to the original problem. And for the original problem, they're asking us to find the maximum profit. So here's our maximum profit. I know, weird, you don't just put 4/13, it's in hundreds of thousands, that's the unit. So you've got to go ahead and put 4/13 of that and put that guy here. And that occurs when, and then convert the 2/13 as well to get your final answer. So here's some more practice. Notice you've got the 4 steps going on. Partial derivatives, second orders. This is just in terms of X and just in terms of Y, so you get both of those. Then do the D test. You get a D that's greater than 0, so you have to do a concavity check. And then go find your Z. Once you have the Z, then you have your minimum value, and that's it. One last problem. For this guy, you have the same thing, 4 steps, 1, 2, 3, 4. Partial derivatives, solve the system. Again, you just get those points. Here's the D test. It's less than 0, so it's a saddle point, and you're done. And so remember, when we're doing these, in this section here, we could end up with squares. So what's possibilities here are squares. You could have to use the quadratic formula. You could have to mix and match. Much like the example that I gave you last week, you really should try that problem. It gets 4 critical points. So you should do that guy. Then when you do the D test here, you could be greater than 0, less than 0, or equal to 0. Remember, equals to 0 means we have no solution. No solution. We cannot say whether there is anything or not because it's equal to 0. When it's less than 0, it's a saddle point, and when it's greater than 0, it's a min or max. And from the min or max, what you have to do is to do a second partial order with respect to X, concavity check. Saddle points get written like this: min and maxes, min value of something at, and then give the point. So go see a tutor if you need help. Sam again tonight, 6 to 8. Hope you're having a great day.